Alright, this is going to be your video lesson for lesson 1.4 on composite functions. Composite functions is just kind of a fancy way of saying that we are combining two functions. Really, it's plugging one function into another function. So for our first few examples, if you look right here, we're going to let f of x equal 2x plus 1. This is going to be g of x, and this is going to be h of x. So if you look at the notation that you see right here, we're always working inside out on these guys. So this is asking us to take the entire g of x function and plug it into the f of x function that you see right here. So we're always doing the inside guy into the outside guy. So if you look right here, we're going to take g of x, which is x minus 4, and we're going to sub it into the f of x function right here for x. So we're going to rewrite this, but instead of x, we're going to put x minus 4. And so that's what you see right here, is just replacing x with x minus 4 in the f function. And you always simplify these as much as you can. Remember, this is just an expression, so there's nothing to solve, but you still always want to simplify as much as possible. Here's just another example. In this case, we're kind of going the other way. We're going to take the f of x function and sub him into the g of x function. So we are taking f of x, which is 2x plus 1, and we're going to take this entire piece and we're going to sub it in right here for x to get our composite function. So that's what this is going to look like. And as always, just simplify as much as you can. This is kind of a good stage where if you want to pause the video and give one a try on your own and then check it, that would be a good thing to do. So on this one, here we're taking g of x, plugging it into h. So if I take x minus 4 and replace my x's with x minus 4, so I'm going to have x minus 4 squared plus x minus 4 plus 3, then we're going to get this look here that you see, and of course simplify as far as you can, and that's where we would end up. With real numbers, it's actually tends to be a little bit easier because you can simplify it all the way down to just one number. So this one again is to say let's take g of 3. So now we get to use some real numbers. So g of 3 would mean I'm going to plug in 3 for x, so 3 minus 4 is negative 1. And we're going to take that answer and we're going to plug that answer into the h function. So again, we said 3 minus 4 is negative 1. We're going to take our answer of negative 1 and we're going to plug that into the h function. So now I'm going to have negative 1 squared plus negative 1 plus 3. And that's what you're seeing down here. This is the better look. This is kind of the more common approach of doing that right here. So just plugging that one into g and taking that answer, plugging that answer in for h, and we come out with an answer of 3. This is just kind of a notation issue that you're seeing here on number 5. This is the more common way that you've probably seen it in the past. This is just another way that it can be written, so just be familiar with this so that you're not confused if you were to see this. But f of g of x, this would read the same way. This is f of g of x. So this is the interior function, and we'd be plugging this into this. So if we were to say g of h of 2, again, that makes this the interior function, so we're going to be doing h of 2 first and plugging that answer into the g function. So that's what you're seeing going on here in the side work for these. And these are still, the setups for these are still coming from those guys that you're seeing up top right here. So again, we're taking 2, we're plugging 2 into h. So we're plugging 2 in for this x and this x. And then that answer is going to go into the g of x function right here. So when we sub 2 in for h, we came out with a result of 9. And we took 9, plugged that into the g function to get our ending answer. I want you to keep something in mind as we go into the next part, because a little of this can be confusing. It helps if you kind of see where it's coming from. So remember that the domain is what you put in. That's your input. So on this one, the domain was 2, and the range was 9. That's the output. So we had an input of 2, that's the domain. We got the output, which is the range. When you do a composite function, this range value then becomes the domain of the exterior function that we have right here. So that might help a little as we get into this next part where they start talking about domain and range. So we start out with just a couple functions here. So we have p of x equaling this right here. We have q of x equaling this right here. And so they're going to ask us for the domain and range of the composite function. So it would help to first find the composite function. So we're taking q of x, and we're going to take all of q of x and plug it into the p function. So we're taking x squared plus 1, and we're going to plug that into this x right here. So 2 times x squared plus 1 squared minus 5. And that's the setup that you're seeing right here. So that was the first step, was just finding the composite function. And it comes out to be this right here. So first thing they want to know is the domain. So remember where the domain of this composite function comes from. As I was talking about this example right here, the range of the interior function became the domain of the exterior function. So that's the key to this right here. The domain of the composite function is the range of the interior function that we're seeing right here. So when they ask for the domain, that's the same thing as them asking you for the range of the interior function. So if we can get the range of q of x, that would become the domain of the composite function. So how do you get the range of q of x? Well, if I have x squared plus 1, what would the range of that function be? Some of you might just be able to visually do this. X squared plus 1 would be a positive parabola with a vertex at 1. So it's at 1 and it's going up from there. So the range of this would be values that are 1 and greater. So y values that are greater than or equal to 1. So that would be the range of the first guy. So now that's going to become the domain of the outer or the composite function. Here's kind of a graph that you can see that might help. So if you look at the red graph, the red one is x squared plus 1. So the range on this, you can see its lowest point is at 1, and it only goes up from there. So the range on this would be y values that are greater than or equal to 1. Since that's becoming domain, we just simply change y to x. So the range was y is greater than or equal to 1, which means the domain of the composite function would just be x greater than or equal to 1. So again, the range of the interior becomes the domain of the exterior or the composite function that we're getting for this. So that's how we get the domain. The range has to do with the very ending result that we get here. So if my domain is limited to x's that are greater than or equal to 1, how can we use that to get the range of the composite function? So if I can only sub in values that are 1 or more, what kind of answers am I going to get? Here's the composite function right here. So this is saying I can only use x values that are 1 or more. So let's test a couple numbers. If I plug in a 1 for x, which is what you're seeing right here, if I plug in a 1 into the composite function, I get 3 as my answer. So that's where you're getting the 3 for the result. So how do I know if it's going to be numbers that are greater than 3 or less than 3? Well, you could test a number. So if I test another x value that's greater than 1, like 2, if I plug in 2, well, I'm going to get an answer that's bigger than 3. So the higher my x gets, the higher my y's would get. So I'm looking at y values that are greater than or equal to 3. Here's kind of the graph approach to that. The green one is the composite function for both of those two functions. So if you look at the green one, remember the domain is x's greater than or equal to 1. So if you find where that would be on here, let's see if I can get it. There you go. So from here, this is where x is 1. You can see the y value that goes with it is 3. So we subbed in a 1, we got out 3. Well, if I'm using x's that are greater than or equal to 1, well, watch what happens as I use greater x's. As x goes up, you can see the y values go up. So if we're going to use x's that are greater than 1, then my y values would be 3 and higher. So y values that are greater than or equal to 3. So there's just kind of a visual. Hopefully that helps. Moving on. solving equations. This is really just basic substitution here. So we're going to use this expression for f and this one for g. So if I have this composite function and all this is telling me to do is to do the composite function and set the entire thing equal to 25. Since I do have the equal sign, this is solving an equation, so I should come out with a one number answer on this. So I'm taking the g of x function, which is this guy, and I'm plugging it into the f function right here for x. So here's the setup. And then I'm setting the whole thing equal to 25. And then if you just get x by itself, you get the result right here. On number 2, if you want to try to work ahead and try this one before I show it to you, that would be a good thing to do. So you can hit pause and give this one a try. For this one, again, it's really just another case of substitution. On the left side of the equation, I have the composite function where I'm taking g and plugging that into f. And so that's what you're seeing right here on the left side of the equation. On the right side, I'm plugging f into g and then multiplying the entire thing by 2. And so that's what you're seeing on the right side. We took f, plugged it into g, multiplying the entire thing by 2. And then from there, you're just solving for x. So that's a pretty simple algebraic equation from there, just solving for x.